These are just applications of either direct or inverse variation. So we're going to pay attention to the variable names, and on example 5 it says the frequency of electromagnetic wave varies inversely with the wavelength. So that means we can write an inverse variation. So it says the frequency varies inversely with the wavelength, and I'm specifically using F and W so that I can keep track of my numbers. All right, so same idea, we got to solve for K. If a wavelength of 500 meters has a frequency of 900 kilocycles, so our wavelength goes in the denominator, and our frequency is over here on the other side of the equal sign. So we're going to calculate K by just multiplying 900 times 500. 9 times 5 is 45, throw in 4 zeros. It looks like K is equal to 45. $450,000. So we can write our direct variation equation. F equals 450,000 divided by W. Okay. Lastly, they're going to ask us to find the frequency associated with a wavelength of 450 meters. So frequency is going to be 450,000 divided by 450, which looks like it's the frequency is going to be 1,000. What's the units of frequency? Kilocycles per second. Okay, example 6. Kind of the same idea. The volume of a gas is inversely proportional to the pressure. This is basically the ideal gas law, PV equals nRT. But we're going to keep it really simple. So the volume of a gas is inversely proportional to the pressure. And if a pressure of 12 pounds per square inch corresponds to a volume of 27, so pressure of 12 corresponds to a volume of 27, then it looks like K is going to be 12 times 27, which is 324. So we get our equation is going to be V equals 324 over P. Sure they want us to use it? Yeah. What pressure is needed to produce a volume of 15 cubic feet? All right, well, we're going to substitute the 15 in for volume, and then we've got to do some algebra to solve for pressure. First thing we're going to do is multiply both sides by pressure, and then I'm going to divide both sides by 15. So basically pressure and 15 change places. You may fill in the algebra steps if you need to see them. Multiply both sides by P. And that will cancel that out. And I get P times 15. So I'm going to turn around and divide both sides by 15. All right. Basically, we need to calculate 324 divided by 15. And again, that reduces to 21.6. So P is equal to 21.6. Just more applications of linear functions, and because we still see these keywords show up, then we know we're using proportional or variation. The length of a spring stretches is directly proportional to the force applied. The length of the string is directly proportional to the force. And if a force of 11 pounds stretches a spring to 4 inches, how much force is necessary to stretch the same spring to 14 inches? So force of 11 pounds, and that stretches a spring 4 inches. So let's solve for K, which allows us to write the direct variation equation. L equals 4/11 F. And now we can plug in how much force is necessary to stretch the same spring 14 inches. So we've got a length of 14, and we are solving for F. Completely recommend reciprocal on this one. So just multiply by 11/4. That'll give us a 1F on the right-hand side. And when we do the math, I get F equals 38.5. And that's it.